Binomial distribution. So before going to the concept of binomial distribution, we'll first see what is a Bernoulli trial. So before learning binomial distribution, we'll see what is a Bernoulli trial. Okay, so a repetition of an experiment is called a trial. So if an experiment is done, experiment is basically something what we do, an event. So if a repetition of an experiment is called its trial. So any repetition of an experiment is called a trial. Now, let an experiment be subjected to a sequence of a finite number of independent trials in identical conditions. So what happens here is that we perform a particular experiment or particular event. Suppose if we are throwing a dice, okay, so if we are performing them finitely, okay, so if an experiment is subjected to a sequence of a finite number of independent trials in the same particular condition, then these trials are known as Bernoulli trials. So what are Bernoulli trials? Bernoulli trials are nothing but sequence of trials in a finite number and in the same conditions what those and in what conditions they are done. Okay, so these trials are known as Bernoulli trials, or and if at each trial we should know that at each trial three things happen. That is, first, the outcome is one of the two. Suppose if we are doing an experiment, so the outcome is basically two, which are mutually exclusive probabilities, that is success or failure. So if we perform a particular experiment, then what we get is we can get a success or a failure. They both are mutually exclusive, so we get only two outcomes, that is, it can be a success or it can be failure. So we can get only two mutually exclusive outcomes. The second is the probability of success remains constant. The probability of success remains constant. The third part, the outcome is independent of the outcome of the previous trial. So we don't have that what experiment we are performing or what outcome we have got in the next time is dependent on the previous one. So what happens is that each trials are independent of each other. So each trials output is independent of each other. Okay. So this is what happens. So now what is binomial distribution? Okay, so coming to binomial distribution, let P be the constant probability of success. We have known that the probability of success is always constant. So we'll assume that P is the constant probability of success. So this is the constant probability of success at each of the Bernoulli trials, and Q that of failure. That is, P is the constant probability of success and Q is the probability of failure. So we need to remember these things, that P is for success and Q is for failure. So in a distributed random variable, X represents the number of successes. What does X represent? Number of successes. Then the probability that X is equal to R, that is, there will be R successes in n trials. So we are performing this, so the probability of R successes in n trials, so we are doing n trials, so the probability of R successes out of that n trials in whatsoever form is given by P X is equal to R is equal to P of R is equal to NCR P R Q n minus R. Okay, so what is R? R is basically 0, 1, 2, that is number of n till n number of trials, and we know that probability, that is the probability of the success, always lies between 0 and 1, because any probability lies between 0 and 1, and therefore Q is equal to 1 minus P, because we know that P plus Q is equal to 1, because success plus probability of success plus probability of failure is nothing but 1. Okay, So this we need to remember. So if there are r successes in n number of trials, then px is equal to r is equal to p of r is equal to ncr. We use the combination p raised to r q raised to n minus r. So now we'll see what the important things that we note here. That is, the binomial distribution is a discrete probability. Binomial distribution is a discrete probability. Then the two independent constants n and p. So we have two independent constants that we have discussed now, that is n and p. What are they? Are known as parameters of binomial distribution. So these are the n and p are basically parameters of the distribution. So the number of trials n, these are the number of trials n is also sometimes called the degree of binomial. That is the number of trials, how much we try is the number of trials is this, is always also called as the degree of the binomial distribution. Okay, so in a discrete random variable x follows binomial distribution with parameters n and p, then we write x as b and p, or x b and p. So we write this. So now we'll see what are the important concepts in a binomial distribution, that is mean, variance and SD, standard deviation. So if x arrow b and p, then mean. Okay, so we know that if x follows, so what does this mean? That x follows the binomial distribution with parameters and np. So this means that x follows distribution with parameters and np. So if x follows, then what's the mean? Mean is denoted by this x bar, or ex or mu is nothing but n into b. That is the multiplication of both the two parameters gives us the mean. The standard deviation is root of n, p and q. So number of trials, so it is the root of number of trials into probability of success into probability of failure. And the second and the third important is the variance. So what is the variance? Variance is nothing but vx. Vx is nothing but phi square is equal to npq, just the multiplication of the number of trials, the probability of success and the probability of failure. So product of these three gives us the variance, whereas root of the product of these three gives us the standard of variation, and n into p gives us the mean. Okay, now what happens is, if p is equal to q, if p and q, that is the probability of success as well as the probability of failure, both are equal, that is equal to half, then probability of our successes in n trials is 1 2 to the power n and then ncr. Okay, if both the probabilities are equal, then we use this formula, that is p of r, pr is equal to 1 by 2 to the power n ncr. So now we'll consider an example where mean and variance of a binomial variate x are 2 and 1. So the mean is 2 and the variance is 1. So what we have to find, the probability x takes the value greater than 1. So we have to find when the probability x takes the value greater than 1, that is p x greater than 1. So we got to find out this. So what we have to first find out is that we have been given the mean. Okay, so mean is nothing but np, as we had seen, and mean value is 2, and variance is the product of the three terms, that is npq. So n, p and q. So n into p and into q gives us 1, as it is mentioned in the question. So so now we have to find out q from these terms. So what we do is, q is nothing but, if we just divide this by this, what we get is q. So variance by mean. Okay, that is equal to NPQ upon NP. So NP gets cancelled. What we get is Q. So what is Q? NPQ, variance divided by Q, that is 2. So we got Q as 2. So we Q as half. Okay. So what? So now we have to find out P. We know that 1 P plus Q is equal to 1. But if Q is equal to half, then P is also equal to half. So now we have found out the values of P and Q, and that have come out to be half and half. So now we have to find out the PR. So PR is equal to 4CR half R and half 4 minus R. So what we have done is basically substituted the formula here, that is PR is equal to NCR. N is nothing but 4, because I found out N is equal to 4 by substituting here. So N is nothing but 4, because so 4CR and half to the power R and 1 by 2 4 minus R. Okay, so now what we do is the probability of X greater than 1. Okay, that means it should be greater than 1. That means 0 and 1 should be neglected. That is 1 minus the probability of X is equal to 0 or 1, because it is given that greater than 1. So 0 and 1 are not allowed. So instead of finding from 1 till the last one, we'll just subtract it by 1. That is 1 minus probability of 0 plus the probability of 1. That is 1 minus P X is equal to 0 plus P X is equal to 1 is equal to 1 minus half to the power 4 4C0 plus 4C1. Okay, that is nothing but 1 minus 1 by 16 1 plus 4, that is equal to 11 by 16. So now we have found out the value of the probability, that is P is X is greater than 1, comes out to be 11 by 16. So now we'll consider one more example where a die is thrown for fixed number of times, and the probability of getting even number 3 times is equal to the probability of getting even number 4 times. So we have been given this condition that the probability of getting even number 3 times is equal to the probability of getting even number 4 times. Then the probability of getting even number exactly for the one time is. So we have been given this thing. So what we have to find is that the probability of getting even number exactly once. So we'll solve it. We'll assume that let n be the number of times the dice is thrown. So n times the dice is thrown. Okay, so n times the dice is thrown. So what they have given, that the probability of getting even number. So when a die is thrown, there are we'll get either an even number or an odd number. So we know that the probability is equal. Probability of success as well as failure is equal. That is P is equal to half and Q is also equal to half, because it can get an even number or an odd number. So half is the probability of success and failure. So probability of getting even number 3 times is nothing but NC3 half n minus 3 half 3. So this is the probability of getting even number 3 times is equal to NC4 half n minus 4 half to the power 4. So this is the probability of getting even number 3 times, and this is the probability of getting even number 4 times. So we have equated them and we have found out that n minus 3 n minus, this gets cancelled, this gets cancelled, because half 3 gets cancelled, 1 half is remaining here, but here 1 half is there, so everything gets cancelled, and what comes out to be is that NC3 is equal to NC4. So after cancelling, what we got is NC3 is equal to NC4. So we can write NC3 as NC n minus 3, because they are complementary functions. Therefore NC3 is nothing but NC n minus 3. Okay, so we'll substitute it in the equation, that is NC n minus 3 is equal to NC4. Now we'll equate this because they both are equal, that is n minus 3 is equal to 4, that is n is equal to 3 plus 4 is equal to 7. So we have come to know that the die is thrown for the 7 times as n is equal to 7. So now what we have to find is that the probability of getting an even number for exactly one time, that is p x is equal to 1. Okay, so that is nothing but 7c1 half to the power 7, that is 7 divided by 2 to the power 7. So 7 upon 128 is the final answer. That is the probability of getting an even number for exactly one time is 7 by 128.